Hello and welcome to this MEI M1 Kinematics revision video where we're going to be looking at January 2011 question 4. So let's read through the question first. We've got a particle which has a position vector with respect to the origin given by this vector here in terms of t. 1, 0 and 0, 1 are perpendicular unit vectors east and north, and distances are given in metres. So we're given that when t equals 1 the particle is at a point P. We've got to find the bearing of P from the origin. That's 2 marks. Then I have to find the velocity of the particle at time t and show that it's never equal to 0. And then finally we have to determine if there are any times when the acceleration of the particle is 0. So let's start by having a look at part 1. So when t equals 1 the particle is at a point P. So let's work out where that is to start off with. So when t equals 1 r will be, substituting 1 in here, we'll have 8 and 10 take 2, also 8. So from the origin, this particle has moved 8 along, 8 up, and it's got to some point P. We have to find the bearing of P from the origin, so I've drawn in a north line here, and so this is what we want. Without doing any trigonometry, we can see by looking at this triangle that it's got sides 8 and 8, it's isosceles, so this must be a 45-degree angle. Therefore, this must also be 45, and so the bearing is 0, 4, 5. So that's part 1. Part 2, from the position vector, we have to find the velocity of the particle. Now, you may remember a connection between position vector, velocity vector and acceleration vector. We differentiate going in this direction, and if we were working in the opposite direction we would be integrating. So from r, the position vector, we're going to differentiate to get v, expressed again as a vector. So differentiating 8t we get 8, and then differentiating the y component we get 20t minus 6t squared. Now we have to show that that is never equal to 0. Well, looking at the horizontal component, which is the east component, east velocity is always 8 meters per second. So actually, even if the north component, which is the second one, the y component, even if the north component was 0, the velocity of the particle would not be 0. Because of course the particle is always moving at 8 meters per second in the east direction. Moving on to part 3, we have to determine the times, if any, when the acceleration is 0. So we have to work out the acceleration vector. Just going back to the previous slide, remember from velocity we differentiate to get acceleration. So differentiating 8 gives us 0. And then differentiating this y component here, we're going to get 20 minus 12t. Now, because it was always going at a constant speed of 8 in the east direction, then the acceleration horizontally or in the east will always be 0. Now, in the northerly direction, this component would have to equal 0 in order that the acceleration of the particle was 0 overall. So solving this equation, we get t equals 5/3, and so that would have to be true in order to get a 0 acceleration overall. Okay, so now we've finished the question, let's go through and see if we can identify where the marks will be allocated. So going back to the first part, we get a B mark for deducing the 8-8 position, and then you get a follow-through mark for working out the correct bearing from your answer that you got previously. Moving on to part 2, you get a method mark for doing some differentiation, and you get an accuracy mark for the correct answer. It must be given as a vector. And then you get an explanation mark for explaining that there's always this 8 meters per second velocity in the east direction. Moving on to part 3, again we get one method mark for differentiating, and then you get a follow-through mark for getting that correct from your previous answer. So from your velocity, have you differentiated correctly? And then we get a B1 mark for identifying therefore the point at which there is 0 acceleration. So that's the end of that question. If you'd like to look at the other revision videos, go to our website www.furthermaths.org.uk.